Okay, let's start. Continue our revision for tomorrow's test. So the test should be about the whole book 3B. And remember, you have to prepare the single line paper for the test. And your necessary stationery and this and that. I will put the test paper to the Google Classroom right before the lesson. You have 45 minutes to finish that. All right? And after that, you need to make a PDF file to upload to the Google Classroom. I will mark it and return to you as soon as possible. All right, so let's start the revision. Well, I nearly shared wrong file. I almost shared the question paper. Oh, where is it? Book 3B revision over here. Now we have really limited time to go through everything. So I will just focus on the questions I would put in the test. Okay? Now, so let's, I didn't share the file yet, sorry. Instead of fooling around, I forgot to share the file. Okay.
Sure.
There will be a question asking you about where is the direction of a certain particle in a longitudinal wave. So last time we have a test. They said test, no, a homework. Unfortunately, quite a lot of you actually did wrong in the homework. So that's why I want to go through that again. And in fact, I returned it to you already. For the homework, you may go and have a look, revise the homework. So you may take a look on this question. But there are a lot of particles, A, B, C, D, E, F, G, H, I, J, K. Can you tell me which direction is going for particle, let's say B and J?
Left.
What is the B and J is left. Okay, let me write down. B, J, what is the direction of movement? Okay, which direction is going? Left. Now, some of you answer me directly because you see that it's not a worksheet. We actually did before. I just want you to take it as an example. You just pay attention to this and understand what is going on. It would be okay. Okay, I don't ask J, I ask another one. Ask maybe H would be better. H. Now I want to know which direction B and H go. Now, I think quite a lot of you will just answer me directly. Okay, B is to the left, H is to the right. That is not correct. The reason is that displacement is to the left doesn't mean that it's going to the left. Do you know what I mean? I could be on the right, but I'm going to the left. So the method to handle this is, yes, we have to change it to the displacement distance graph. So we first look for those points with zero displacement. Oh, sorry. Can you locate these 3 points? A, E, and I. You may see that they have no displacement, but we see all these particles, B, C, and D are all going to the left-hand side. And all the particles at this region, F, G, H, are going to the right, right? So that means this region will be having negative displacement, and this region will be having positive displacement. So what we can do would be like this. This is the displacement position graph. If I want to know whether B is going forward or backward, or going to the right or going to the left, we may need to shift the graph to the right a little bit. I use the left hand to shift that to the forward. Like that, right? So you may notice that the B, this point, is actually moving to the positive displacement. So B is moving to the right. This is how we handle the question if it asks whether a particle going to the right or going to the left. And H is here, is also going to the right. Understand what I mean? So you need to revise these parts. This is the notes. Oh, sorry, let me erase everything. Be able to convert the information into a graph like this, okay? So that you can tell whether it's going forward or backward. All right, now this is the first part of the chapter 8, chapter 7, longitudinal wave. And then when we talk about the sound first, sound exhibits all the possible wave phenomena, including reflection, diffraction, refraction, interference. So you may study this on your own. And there's some property of the sound and light comparison. So you may refer to the notes here. And other thing is the supersonic or ultrasound. Okay, ultrasound. What are the property of the ultrasound? It includes what is the meaning of audible range. Our ear can only hear from 20 Hertz to 20,000 Hertz. Okay, this is the range our ear can actually hear. If the sound with larger frequency higher than 20,000, we will call that ultrasound. Okay?
Sir,
Yes,
sir,
question?
is there negative frequency?
No, no such thing, because frequency is having no direction. It could be just like telling how many times in 1 second, right? So I don't think it's meaningful to include positive or negative. All right.
Sir, what will be in the exam? Like what type of question?
There will be MC question and short questions. I'm telling you actually.
Sir, but Miss Lee said that there will be only one type. So it's either multiple choice or long questions.
For some subjects, if they have separate paper, you will have only one paper. But for us, we have both.
Sir, do you guarantee that I will not get coronavirus if I come to school?
So you need to ensure that you have mask with you, and yeah, always wash your hand before.
Sir, you're not answering my question.
Jovan told me he has symptoms.
What?
Sir, you 100% tell me that I will not get coronavirus, then I come to school.
Yes.
100%.
It's up to you.
Jovan, shut up.
It's
Sir.
up to you.
Look at his beard and his mustache.
Sir.
He has some kind of.
You can
shut
trap
up,
yourself
shut
at
up.
home.
You better give me a whole bottle of sanitizer before
I
coming to
really
school.
have limited time. Don't talk about that.
I'm trying to
Sir.
pay attention, Jovan. Shut up.
Or you
Sir,
go to
it's
class.
about our
Yeah,
life.
that's for you.
Hey, Alex, stop being extra.
One day, sir, come on. He
Sir,
needs
it's
help.
about my life. Sir, I love
he's
my life.
advertising.
Jovan,
Out.
okay, I have to stop you. If you keep looking this sound to ask question and something a lot related to the vision, I will
How
need
is it
to.
not?
I will need to
Let's
remove
kick him
you
out.
from the class.
Wait, Alex, shut up. You're just a kid, man. Just shut up.
Okay, let's have a look.
Stop crying, man. Stop crying.
Okay, enough.
Alex, you're a piece of shit.
Apart from that, we also have the sound, the musical notes. There will be 3 things you should be able to identify. They are the pitch, loudness, and quality of sound. Okay? For the pitch, it talks about whether the frequency is high or not. When frequency is high, that means the pitch will be also high. Loudness would be related to the amplitude. Okay? Amplitude. So larger amplitude means larger loudness. And the quality is the shape of the waveform. The more smooth of the waveform is, the more comfortable sound we will hear. So this is the things you should be able to read from the waveform. Let's say you're given the waveform, you should be able to compare their pitch, loudness, and their quality. But usually question would ask pitch and loudness, okay? If the wave is more compact, like to pack closely, it would be having higher pitch. If the wave is like so far away from each other, you have a long wavelength, it is having a lower pitch, okay? So be aware of these three factors in the musical notes. All right, and yeah, this is not really important for the coming tests. Sound intensity level, and there's a table for you to revise. Okay, now let me tell you, there will be 3 long questions, all right, in the test. 3 long questions in the test, and what are they? Let me tell you. Okay, first, something I talked about that yesterday. It is diffraction grating. So let's say number, I will ask a question like number of lines in 1 mm. I call it n, okay? N, or n lines in 1 mm. Would be another one is called a line separation. Okay, how are they related? N and D, how are they related? Can someone try? I think time is really limited. I will just tell you then. Sorry. D is equal to 1 mm divided by N. Now, so make sure that you know how to do that. And for 1 mm,
Sir, you're confusing me again. D or A? Which one should I use?
it's okay. Both of them are okay.
Sir, I am confused.
That's
Very
okay.
confused.
You try to live with that. A or D are both okay.
Get well soon, Jovan.
Okay, now get ready
Tell you
for
more,
this
but don't contact
change
me,
in
yeah?
unit. Now there will be a question asking that, and then you'll be given the theta 1. You'll be given theta 1, and you need to look for the wavelength. If D is given, you have equation, right? D sine theta 1 equal to n lambda, right? Surely n is equal to 1. So if you look for the lambda, that means if you look for this lambda, you only need D and theta, right? If both of them are given, you can find this easily. So yeah. And the other way the question would ask is, let me erase this part first. The other way around would be I give you the theta, this is given. And I tell you this is, let's say, another order. I want to know which order, n equal to a certain order. So what we can do is the same equation, d sine theta equal to n lambda. If we look for this unknown, that means you need to put the correct value of lambda and then correct value of d and correct value of theta so that you can find the n. Is it okay? So always make good use of this equation, depending on the unknowns or the value the question will give. Okay, this is the first long question. Second long question. I forgot the second long question, certainly. Okay, forget it. Let me go to the
Fooling
third.
around.
Yes, really sorry about that. Because I prepared the third question. But have a look on the video I'm going to give you. Share. This one.
Hertz.
Oh no!
This frequency
It goes
is known
away.
as the fundamental frequency. Standard
How can I
waves, they
go
contain
back to
multiple
the
frequencies.
this one? Actually, I don't want the music. I want to show you something. Now, this is a stationary wave in slow motion, okay? Let me look for this one. I don't want the music, really. Sorry. Okay, now, so first, do you know how to identify the position of knobs and antinobes? Knobs Is the point always stationary? Okay, so if I really, the loop is somewhere here. Okay, this is the loop, and don't move the camera. And the antiloops are the points with maximum amplitude. So which point is having the largest amplitude? So let me show you. Maybe I need to find another. Oops. Wait.
Alex Molek.
哎呀，點解冇嘅喂？呢度啦 ，OK。Where is it? So fast. Sorry. Once again. So where is the antelopes? It's at this point. This is antelopes. And these points are the lobes, okay? But notice that this one is having maximum displacement, A. You can reach a large amplitude here.
Sir, are we talking about stationary waves?
Yes.
Okay.
Now this is the amplitude of this particle. But for other particles, its vibration is limited within this envelope, within the outside envelope. This is the envelope of the stationary wave. So each particle may have different amplitude. Understand? But they will reach their maximum displacement at the same time because it swings up and down altogether. Okay? So be aware of the word's maximum displacement. That maximum displacement actually refers to the instant all the particles reach their maximum displacement. So later on, they will just like going backward, returning to the straight string shape. Well, let me erase and show what's going on for the like this. Okay? This is how the particles are moving. Any questions for that? First, can you identify the lobe and antilope? Okay.
Yes.
If you can identify that, so let's say if the question gives you a certain shape of the wave. Let's say this is at t equals 0. And the question already tells you this is at its maximum displacement. All right, now, so let's say this is particle A. I want you to draw the displacement time graph for A. Particle. So what should we do? The only thing we need to do is, I know that at time equals 0, it has a certain displacement, right? So you may just locate this point. This is the point this shape actually gave you. And it's already at the maximum displacement, right? So that means at the next instant, it has to be going backward, going back to the original position. So this is how the shape looks like. This is the shape of the particle A against time, the displacement time graph. And this is the period. Okay, for the lobes, let's say we have another particle B. For particle B, what would be their displacement time graph then? It's actually very easy because it has no movement at all at any time. So the graph would be just like having at this point. But if I ask you the question like, well, where is the particle C? If I want to draw the particle C, I will draw it on the same graph here. Notice that the question already tells you all particles are at their maximum displacement. That means C will be somewhere here. But since it is always moves up and down together for all particles in the same loop, they always move up and down together. You see in the video, right? So the particle C would be having a shape like this. They are synchronized. They move up and down together, but it's just like moving within a smaller range. This is the displacement time graph for particle C. And I also draw another one, particle D. Particle D is also at its maximum displacement because all particles reach the maximum displacement at the same time. So we may locate this point first. Now, for the particle in the next loop, the blue one, this is the particle in the next loop, it's always moved up opposite, in the opposite direction with the original one. So for particle D, the shape of the wave will be like this. Okay, this is particle D. Now, so you may spare some time to understand that because you will see a question asking that in the test tomorrow. Is it okay?
Yes.
Okay, thank you, thank you. Now, so since I suddenly forgot the question 2, I need to have a look at that. And I have to be careful and preventing share the test paper to you. So give me 30 seconds. It seems it's a interference question. Let me check.
Sir, from
yes?
book 5, from where to where will the exam come?
Sorry, I can't hear you louder.
I mean, sir, from book 3D, which chapter will come tomorrow in the exam?
All chapters.
All the book?
All chapters, yes.
What?
What?
Nothing,
How come
sir.
you ask me this question right now? I have been talking about that for
No, just to
many
confirm,
days.
sir.
Huh?
Just to confirm.
Oh, just to confirm. Now, so let's.
Yeah. Also chapter 6.
Yes, all chapters.
Okay.
Now let's go back to
Alright.
the revision here. I start a new one. 呢做咩係呢個嘅？Let me clear. Can you see that? Okay, now there will be a question like this. You have two sources. Let's say I want to know at this point, the second point P, what would be the path difference of it if this is given? Let's say this is 4 meters, this is 3 meters. So what would be the path difference? Can someone tell me? 佢做乜事咁樣嘅? Oh, sorry, I don't know what's happening. Something wrong with my drawing. Okay, let's say this is source A and B, and it is given like this is 4 meters, and this is 3 meters. So what would be the path difference? So path difference would be equal to BP minus AP, right? So we need to use Pythagoras theorem to find that. Y1 wavelength. Not yet. You have no idea how many lambda there. You need to find this first. BP, this length, is equal to 4 square plus 3 square, and take square root, yes, 5. So you may need to use Pythagoras theorem tomorrow. It will become 5 minus 4 equal to 1 meter.
Sir, what are the chapters for tomorrow test?
You are still asking me this, I think, whole book 3B.
Oh, sir, but how is this related to waves? It feels like motion.
What motion?
Sir, how is this related to wavelength, whatever? The wave stuff.
Now, we are
Path.
talking about sound wave to sound speaker with the same source
Sir, I
emitting.
remember, no need to explain now.
Sir,
So
Thank you, sir.
cooling around to.
sir, he's trying to ask how will the test be conducted?
Huh? What do you mean?
Is it open book?
Yeah, you can open your book if you want. I don't mind. Because I can't really see whether you're using the book, but the most important thing, you need to finish all questions within time.
Sir, can I use my phone to answer the questions?
Answer question by phone.
Yeah.
I want you to do it on a paper.
No, I mean like use my phone to find the answers.
I don't think you can find that.
How about I ask somebody's like really smart in physics?
I trust you guys. You use your ability to handle the test. Okay? This is a test for your review, but not for the score. Is it okay? All right, now so this is the path difference. And remember, this path difference could be equal to n lambda for constructive interference, okay? So I can ask something else here because I can ask what are the possible frequencies that would be having constructive interference at this path difference. That means I can ask a question about frequency instead of lambda. So what we can do, I can just use this equation, V equal to F lambda, right? So that I can change the subject into lambda equal to V over F, isn't it? So that means you may choose N V divided by F, which is equal to 1. So V would be given, and N are integers. So that means from this, you may find out all possible frequencies. Is it okay? So at a certain point, it has a fixed value of path difference. It could be different value of f satisfying this relationship. So I want you to find out the possible frequencies in this case. So that would be another long question. But we always begin with path difference, okay? Be able to find the path difference. And sometimes you may need to use Pythagoras theorem. Any question? No question?
Sir, so let's go back to my topic.
Which topic?
The
Yes.
exam topic. Do you guarantee that I will be alive after this examination?
We won't guarantee, but you know, every day when you go out, you have some risk.
Sir, I never went out since December.
I talk about MC. Actually, I talked about the MCs yesterday and also today. The part I stress more are actually for the MC questions. Like, do you remember I talked about the double slit experiment? What happened to the separation if I change the color? Right? There was something like this. Provide all equations and okay. Now I will be sitting in front of you. So if you got any inquiry, you may let me know. I may write some equations on the screen. Some of you asked whether I will provide equations. Yes, I will provide some equations. You may ask me, you may send message to me or anyway to ask me questions during the test too. But again, we want to remind you again, make sure that you prepare a single line paper and answer all questions on written. Don't type anything. I want a written answer. So when you scan the paper, use PDF file. I want to see PDF files. with good quality, reasonable good quality. So that's the end for today. Get ready. Get ready. Bye-bye.
Hi, sir. Thank you.
Bye,
Bye-bye.
sir. Thank you.
Yes, sir.
Bye, sir.
Yeah, get good preparation.
Bye, sir. Have a good day.
Yeah, you too.
Good afternoon.
Bye-bye. Oops, yes.